So like creating the first little bit. We're gonna do cargo new, and then the name of this entire thing. So we're gonna call this the GGEZ runner 2. It creates our binary package for that. I'm gonna cd into that and open up code here. So several things to notice. It gives us like a hello world here. I can compile and run this with a cargo run. That's sort of like npm start, and I get my hello world. That's a pretty fast compile time, but just sort of like a heads up, compile times are like not the primary focus of the Rust language team. It is something on their mind, and they are improving it, but they're focused on other things as well. Okay, so we got our hello world. If I want to bring in GGEZ and just get something going, we're gonna go into cargo toml, and this is the equivalent of a package.json. So I'm gonna bring in GGEZ. Hit save. I have an extension that tells me what the latest version is. If you didn't know what you wanted to put in here, or even like what the packages are, there is a package website exactly like npm called crates.io. And so we can come here and search for these crates or packages. So search for GGEZ, and here this is. And we can see it's 0.51, and they actually suggest here, just throw this in your cargo toml. Mark, so the function main is executed automatically. Yes, function main in the file main. And that's really important because I can add, we're going to add new files, but main is going to be our entry point for this. And this is, I think, a hold off, like it's very similar to like what you find in C. I still have these checks going down here. You might see like Rust Analyzer and my cargo check is doing a whole bunch of things behind the scenes. These are tools that basically give me the autocomplete and sort of like a lens into what's happening in the program. It's actually really nice. Extensions for this. I have it's called Crates by Sure Uzgar. What else? Obviously just Rust. Rust Analyzer. Really, really cool alternate, but kind of works with everything else for analyzing what is happening in a program and like displaying what types are. And that's it. With Rust, I get RLS, which is just an alternate for like the original Rust Analyzer, essentially. All right, so I'm gonna put into GGEZ, we have 0.51, hit save, and immediately, just by doing this, I believe that my compile time gets much higher. So if I do cargo run, it's now pulling in and having to compile all of GGEZ also. So I like to do this like right at the beginning because this takes a while. Back when I was on my notebook and streaming there, it was taking minutes, several minutes, and like that was less fun. On a desktop with multiple cores and a lot of memory, much, much, much better. All right, so still a hello world, but GGEZ has been compiled. Okay, so we're ready to go. And one other thing that I have here, I'm gonna turn on my Twitch highlighter. What this means is that you can do bang line and it will highlight a line. You can even do bang line space and a message. It'll highlight a line with a message in there. And that way you can like point out if I make a mistake. You can ask a question about like what's happening on this line. You can even highlight multiple lines, like an entire section. It is whatever I have open on my screen at the time that you send the message. All right, Shall we get started? We have GGEZ brought in. Let's go ahead and get ourselves just a screen going for us. So because I've done this many times now, I actually ended up creating a snippet for myself. And don't worry, I'll go through everything that we do, but I'm gonna do gmain, and this sort of brings up a bunch of this. So use, that's an import statement or like a require statement in Node. Okay, so GGEZ is the library that we have, and we're bringing in event and context builder, essentially objects. Use crate name, that's like my main crate name. So this is GGEZ runner 2. And I'm assuming that I'm gonna have a game state method in there. Just testing, yeah, that's fine. I can actually come in here and delete these when we're done processing them. Now it's yelling at me because I haven't created this game state yet, but that'll be next. Here we have our function main. Oop. I wanted to, that's fine. I said that's fine. Fine. Okay, well, I screwed up by clicking somewhere else for my my entire snippet here, but you're supposed to send my cursor to the next things. Let's go ahead and save this and get the indentation automatically fixed up. Okay, so we have our function main here. Let context, so okay, we're gonna create this context, which is return to me from this context builder. We're gonna create a new context builder. Dot things, dot is exactly the same as JavaScript. Whatever context builder new returns, we then run the dot build method on it. : I'll explain a little bit more in detail later when we create our own, but it allows us to reach in here. It's basically running the static method new on the, there are, I'm getting a little ahead of myself, but context builder is the equivalent of a class. All right, so we're gonna hand it the project names. This is, and the author me. Okay with this, and error with this. All right, so this is a little bit interesting. We have this match, which is basically a really interesting switch statement. So I'm just saying, hey, match off of what's returned from this build, and it's either gonna be an okay or an error. If it's okay, I want you to do this, but Rust is a much more functional language. So it's kind of returning what's happening from here into this variable, these two variables, context and event loop. There's some destructuring going on here. And of course, if it's an error, we're gonna panic, which is just a straight up quit to the desktop and print the error. So then we're gonna create the game state from my yet to be created game state, and we're planning on using the static method new. We need to make it mutable. Rust, everything is not mutable by default. So we're gonna have to deal with that. I'm gonna take this event game state and hand it along with the context that we created and the event loop to the event run. So this is all provided to us by GGEZ. If we're creating like our own game engine from scratch or something else, we would obviously start very differently. And then this code is what happens when we exit the game. All right, I think it'll be a little bit easier to follow. Like, we don't need to touch this file essentially anymore. We now need, okay, so this game state. So we need a library and to pull in the game state. So when I say like use infinite GGEZ runner 2, which is the name of our entire program, it's assuming that I have a library file here. So I'm gonna create that, lib.rs. Inside of lib.rs, I need to create this game state for it to find. So I'm gonna save you, and I come here and I need to make this public so it can be, anybody outside of this file can have access to it. So that's sort of like the module that exports, or just export if you're using like TypeScript or something. So pub struct instead of a class, you know, just subtle differences. And then game state. And then whatever is going to be in there. So right now I don't have anything that I really care to have inside of the game state. And that's it. Now over here, I do find that I need to restart the Rust server for it to like find that quite often. And then now it's yelling at me. No function or associated item named new found for struct GGEZ runner 2 game state. Okay, so it's yelling at me saying, hey, I'm looking for this method new in here and it's not in. So let's go ahead and do that. So to add this in, I do something called an impl block. So I'm going to impl game state. And inside of here, I can create a public function new. And then this is a typed language, so I have to tell it what type we're returning. So thin arrow type is going to be game state. I'm returning a new game state. And then in here to return the game state, it's game state, and then the curly brackets for what this is. That makes part of this happy. This is now happy now. However, now it's saying the trait bound event handler is not satisfied. So this is yelling at me saying, hey, we want you to do the equivalent of inheriting. You need to inherit from the GGEZ event loop, essentially, or event handler. Now, I say inheritance, but there's no real inheritance in GGEZ. We're gonna have to do all of this ourselves. So to implement this like trait for it, we're gonna use GGEZ. So we have to pull it in first. What is it? Event handler. All this code you could find on GG's website and just like pull it in. I've memorized some of it. And so we want to now implement the event handler for the game state. And we're going to do a very similar style to this. It's going to be impl event handler for game state. And now we can create these functions that are created and defined in event handler. But we need, like, they're essentially, it's an interface, right? Event handler is an interface and we need to implement it now. Okay, so what was the first thing it's yelling at me? Not all trait items are implemented, missing update and draw. So, okay, update. This is Rust Analyzer did this for me. It's super nice. I just start typing it and it just auto-completes it, the best. All right, so we have a function update. We have access to self here. This is the equivalent of the this keyword, except it's injected in to the method. So you always know exactly what it is. In this case, self is also mutable. It's a reference to whatever is stored inside of here. Then we have context. So I'm gonna just rename this to context. It's yelling at me because I need to pull this in so it knows what that is. So let's go ahead and do that. Context. And then game result. Okay, so it's looking for game result. I happen to know that that's also in this base version, so game result. If I want to pull in multiple things off of GGEZ, I can do that with these curly brackets. Now it's yelling at me, not because I don't have it in here, but because I'm not actually returning a game result. So let's go ahead and do that. A game result. So a result is a very special type. There is no null. There is no, well, there is a none, but there's no null, which means that if I want to return essentially nothing at all, I have to either like just say, look, I return, like doesn't return anything, or in this case, it returns something like nothing or an error. And we can see that here. It's expected in this result or an error. I don't have an error to return, so I'm going to return a result, which is okay, and then basically empty parentheses, which is nothing. And that will make that happy. Next up, you're yelling at me because I'm missing draw. Let's go ahead and implement that. It's exactly the same thing here. We have context. We return a game result. I can do okay like this, and that'll make that happy, but this won't actually draw anything to the screen. Although maybe I should wait for a second so that way I can run it first, and then I'll show you it not drawing. I have some warnings here. So it's Rust comes with, for free with essentially a linter and an auto formatter. So RLS / Rust Analyzer will also format our code for us. So that way everybody in the entire world who's working on Rust projects, all of their code is formatted in the same way and linted with the same rules. It's super nice. It's telling me that I'm not using this variable, and that's not good. So I can put an underline on here, which tells the compiler, don't worry about me not using these variables. Ignore these warnings. No problems with my entire project now. Let's go ahead and run this and see what happens. With this code, I have basically this, a white big box with my title, an easy, good game. Okay, that's interesting. It's not very helpful or nice. Let's go ahead and make the background. Do we want to make the background black? Nah, let's actually draw a circle to the screen. I just want to make sure that we're drawing things correctly. So in draw here, I want to create a circle and then put that onto the screen. So we're going to create a variable. We always create variables with the let keyword. So let, I'll just call this a circle equals, I need to create a mesh. So I'm going to come up to here, use GGEZ, graphics. We're going to need a few things in here. We're also going to need graphics itself. So let's bring, just putting it as part of this chain doesn't bring graphics in. All right, so I need a mesh. Do I need a mesh? I only need a mesh builder right now. I'm also going to need a draw param and a draw mode. And I want to say that that's it for right now. So let's create a circle. It has to be created from a mesh. So we're going to do a mesh builder. So that's that new builder pattern here. And then I could do dot circle. And so it's asking here, okay, it wants a draw mode. Okay, so draw mode. And I'm going to tell it to fill. So just going to fill that together. A point. Oh, it needs a location of where it's going to go. Okay, so GGEZ exposes another library called nAlgebra. And I'm going to use point2 from that. Point2 is kind of, sort of like, but not exactly, the vectors of P5.js or processing. There's also vectors in algebra. A point2 is essentially a scalar point, which is just a point somewhere. So it's basically XY. All right, so point2, new. Where do I want to put this? Let's just put this like 200, 200 to the right and like 200 down. Now notice this is telling me, I'll wait until it like yells at me about this specifically. All right, radius. How big is this going to be? Let's make this like 200. Tolerance. So tolerance is interesting. This is how many points, like sample points around the circle. If I do a really low tolerance, like I think I can do like 2.0, it's not going to be a circle. And then a color. What color do we want to use? We can actually pull in a color off of graphics. And once again, do the color new. And then this is asking me for a number between 0 and 1 for it. So if I do, let's do green. Let's make a very solid like green. So 0.0, 1.0, 0.0, and then the alpha 1.0, so fully solid. I'm gonna save this, and let's see what it's yelling at. Okay, so this creates, what are you yelling at, Matt? If I go down to the bottom here, I'll see the error message. The trait bound point 2 of type F32 here is attempting to convert from a point of type integer. So it's yelling at me saying, hey, look, you gave me I32s. If I mess over this, it actually thinks these are I32s. However, it requires F32s. So it's not able to auto convert this or cast this. There's a couple ways I can deal with this. I could just do .0, and that will tell it, hey, you should probably be a floating point number. The other way is I can just end this with an F32, like that, and that's the exact same thing. It'll handle that for me. Personally, I like this a little bit more, but different programmers are different. They're both perfectly valid. Same exact thing with radius. We need this to be an F32. And now at the end here, it's yelling at us because we need to do something with it. So in this case, there is a .build that we need to add in, and here we add in this context. So let's get rid of this underscore and hand in the mutable context and semicolon. It's a semicolon language. You cannot skip that. Now, what are you yelling at me about? Type ascription is experimental. Expected a semicolon. I have a semicolon. Did I not? Do I need to restart the server again? Not that one. Restart that one. Oh, yeah. You know what? I forgot here. I don't need, it's yelling at me because I'm actually telling it what type it is. I don't need to tell what type it is. I need to just use it. That's what the problem was. So Rust is a strongly typed language, but at the same time, it's attempting to make it so that you're only having to do the types inside of the function, what we call signatures. If you're not familiar with that word, it's more of like a computer sciencey term. It's basically this definition of the function right here. So we have context, we declare its type, and we return this type. That pretty much means that it can figure out what the types are everywhere else for us, for the most part. And there'll be a few times that we can't do this. Rust Analyzer here is injecting some text here for us to let us know what types are, just so that we don't have to like mouse over to constantly see, ooh, you're this results type. So this is actually a problem. I want this to be in mesh and not a result. So I need to get rid of a result, there's a couple ways we can handle this. I can do something called an unwrap. Unwraps do work. They unwrap the result and then give us the value or crash the game if the value isn't there. Not exactly the best thing in the world. There's shorthand for this. The other thing that we can do is essentially return the error, because they're going to give us a game error if it is an error. So let's do this. We're going to let circle equals, and we're going to match off of this mesh builder. And then we're going to have an OK. So if it's OK, parentheses, and we're going to get the mesh out of here. Fat arrow, and this like pretty much just for this. Is it the only time I want to say yes? I might be wrong. But fat arrow in this this match syntax, and I want to return the mesh. And then, of course, if it's an error, I want to get this error, and I want to do an early return, like a return to the entire function. And then, let's see, what is it? A error. And then I have to semicolon this, and now I have the mesh inside of circle. Okay, this works also for us, but if I, like every single time, this result pattern is very, very, very popular. That means I'm gonna have to do this match everywhere. It kind of sucks. I'm saying that we're gonna do this return game result. I don't want to do this match. It's just too much typing all over the place. So I'm going to come back up to build. There's shorthand for exactly that thing that I did. Question mark. If I just type a question mark in there, it's going to do that match. If it's okay, it passes in the value into my variable. Otherwise, it returns a game error. Can you do the match return okay on anything? You can only do the match return okay error on things that on result, the things that return a result. There's other times we can use match too, and if we get into those, I'll show them out. I'll point them out. The question mark operator, it just helps us clean up the code and make it really nice. We can only do this if we return a result. Okay, so I have this circle. Let's draw something to the screen. We're gonna do graphics draw. It takes in this mutable reference to the context, and then it wants a reference to the mesh, or there's several things that implements drawable as the trait. Basically, it's okay, it wants something that can be drawn to the screen. A mesh is one of those things. So we're gonna give it a reference to the circle, and then any params. This is why I brought in draw param. I'm just gonna create a new draw param. I'm not gonna override any defaults. Again, draw. If I do semicolon this, it technically works, but I get a warning that I'm not handling the result, which means that I might have an error that I'm not handling. So Rust kind of like, it's not forcing us, but it is yelling at us. It's very unhappy. So another question mark here. And this should draw out to the screen. So let's go ahead and cargo run this. But it didn't. So what's going on? This is actually, this took me forever. I had to reach out to a couple friends who are using GGEZ and like find out what is going on. Why didn't this draw to the screen? I'm missing something that finally is in the documentation everywhere. But we need to do graphics present, hand it the context, and a question mark for this. And this actually presents the things to the screen. It needs to run at the very end of the draw. In fact, because this returns a game result, I can skip this OK here and skip this question mark and return this, and it's fine. So you may have noticed no semicolon on these lines. This is because if it's the last line in whatever, like the function that it is, that is, the result of that is returned. So I am returning a game state. I am returning an OK. I am returning the result of present. It takes a little bit while to get used to, but once you have it, it's actually really nice. What that really means is that if I do anything up here and I want to return early, I use the return keyword. So the return keyword only happens when you return early, which makes it a little bit easier to sort of like see, hey, this is like something interesting is going on here. All right, let's try this again. Here's our circle. You may notice that our circle is not very circle-like. It is not. That's because we gave it 2.0 as part of this tolerance. If I gave it like a 0.1, it'd be very much like a circle. All right. Let's now figure out like the location of the circle and maybe update that and have it move across the screen. I'll just leave this down there behind me. Okay, so if I want state across runs, I can give myself like, it will go in there, but first I define them in here. Here's the types that I want to store inside of this game state. Let's do a like X for location. So let's do X of an F32 and a Y, which is going to be an F32. And then in here, I have to like give that. So X, let's set this to be, what do we decide on? 200 and 200. I'm going to do 200.0 and Y is 200.0. And now it's yelling at me, I'm not using these. So let's come down here to draw and switch these. This is going to be self.x and self.y. Everything else is fine. If I restart you, nothing is different. Everything is the same. But now I want it to move. So in update, I'm going to say self.x. There is no plus plus in Rust. I can't do that. It'll actually yell at me saying like, what is this second plus? Which is why you might notice that I just don't use plus plus very often in other languages now. I've just gotten used to this and I like it a lot. But I can do plus equals to that. Now I can't do like 1 because it's saying, hey, you're trying to add an integer to a float. You can't do that. You're gonna have to cast and convert that integer into something else. So I'll just turn it into a float. Now our X is gonna make it move across the screen to the right. Well, that's lovely. It just smears across the screen. It doesn't move cleanly. P5.js actually has, or processing has this exact same thing. At the beginning of my draw, it's like this, the draw is saying, hey, okay, we're just gonna bundle up whatever you're drawing here, and it sends it to my graphics card, and it displays it. But every single frame, I need to clear it and reset it, so that way it's, you know, something new. So let's try that. We're gonna do graphics clear, hand it the context, and then a color. So I can make it whatever color that I want. So we can just have a, for example, we can put a background color in here. And define that in here. We can make this like a black, a really dark blue. There's like black and white are colors provided to us in graphics. They're literally just like, you know, the exact same thing that I could create. They're just created for us. But if I want to do color new, what's background color that I should do? maybe like really close to black. Maybe, let's see. Do I want anything off of here? Like maybe one of these like really dark colors. In Firefox, I really like the fact that I can come into the inspector. Where is it? Here, this eyedropper. Let's grab this blue. It copies that to my... Oh, it's that one. Okay, that's not helpful. I wanted that to be a RGB because unfortunately GGEZ only supports RGB and not like anything else. So that's not helpful. Let's go find color RGB, like a table. Maybe something like this color. That's 0, 51, and 102. Of course, I need to convert that to 0 to 1 or use a different method. I don't have to use new. There's other methods here. So I can do from RGB, and this one gives me 0 through 255 as U8s. So U8s, there's many types of numbers. Like in JavaScript, we're used to having, it's a number. We got a number, that's it, just one type of number, which happens to be a floating point 64-bit number. Might be 32, I can't remember. But it can be really big. U8, so the U stands for unsigned. This confused me for a little bit. The unsigned is really simple. Signed means that it could have a negative on it, meaning it can go negative. U is unsigned. You can never have the sign on it, meaning this number can never be negative. It has to be 0. And then U, like the 8, is how many bits of data it takes up. It just happens to be like 8, so like 1 and then followed by 7 zeros. If you're like a binary person, that would be 255 is the largest number that a U8 can be. So if I do this, we can come and look at yours again. 0, 51, 102. So 0, 0, 51, 102. Save that. And now in this color, we'll do self.background color. Run this. Oh, we got an error. Unexpected, expected a colon. What happened here? Background color. What was I expecting this? Library line 10. Oh, it wants to know what type this is. This is type color. The errors here are really nice. It actually tells me, hey, look, you kind of wanted one of these things. You probably want to put a colon right here. It even shows you the code that it is. Super, super, super nice. I actually have 3 errors still, so let's see. I expected semicolon somewhere. Oh, I need to semicolon that. No errors. Go ahead and run this. And there you go. We got our background and our circle just sort of moves along and everything is good in the world. One other thing, if I want to make the world bigger and like change the size of the screen, I can do that when we first start up the game. I don't know if we need to like care about that right now. Probably. So that's like the basics of like starting up with Rust, starting with GGEZ, getting something on a screen and having it move across. So let's go ahead and do a little bit of a reset here. We don't need, it's generally a bad idea to create our meshes in the draw loop. You notice that we need just a reference to them, so we don't need to create them every single frame. I'm not gonna store you there. We can create our background color, that's fine. But we're not gonna keep all of you. All right, so we've got a nice basic reset. That'll just give us a window with a background of blue. Okay, so if you remember from yesterday, if you were here yesterday, let's go grab this. Let's see. I'm in Windows, so I have to do it this style. We're in the P5 Runner 2. And there was a, what was it called? Something that JSON, our game data, that's what it was. Game data.js, I want to copy this right here. I want to put this into source. Actually, I don't want to put it into source. So here's our game data. I actually want to convert this into actual JSON. Okay, so let's go ahead and make you happy. All right, so no errors here anymore. All right, so here we're going to be defining like what everything is going to be on our game. Specifically, our camera width and our camera height. That's essentially going to be what we want to have like the size of the entire window. So if we do this, that means we're going to want to bring this in and like store it into a struct. So it's been a while since I've done this, so this will be a little bit interesting. But let's go ahead and I'm actually going to end that marker. So that was the end of the first video, is going to be setting up the just like the basic game, the game window. So